In this lesson, we're going to spend some time on different sequences, how to generate them and how to manage and order them. So let's go to our Sequence tab under Sets, which is located here. Now the first 5 components remove items from a list using different calling methods. I'm sure you're familiar with those. I want to give you one tip though, and that is if you find yourself using the curl pattern, I would strongly advise you to use the dispatch component instead. And let me show you why. So we start with that. Let's insert the curl pattern. And also let's insert the dispatch component. Now let's say we have a simple list with numbers in them. So let me insert a panel component. Or better, let's insert a series component. Now the default is already set for the series component, so we have a series of numbers that start at 0 all the way until 9, as you can see here in this panel. Now let's connect this panel also to the curl pattern and also to the dispatch component. And let's insert a panel to see the result. Let me copy it one more time also for the dispatch. And the last thing we're going to do is to insert a culling pattern, so they're the same for both components, because I think for the dispatch the standard is set to true false, but for the culling pattern it's set at false false true true, so it's a little different. Nice, so we have the same pattern for both, so we can compare them. Now the thing with the curl pattern is that it does its job well, that it culls out the items you don't want, let's say the false items, which in our case are the uneven numbers, so 1, 3, 5, etc. And it only spits out the values that are true, which are the even numbers. The thing is that if you use the dispatch instead, you both have the true values and also the false values outputted in the A and B output. So that is really nice. So if you take a look at the dispatch, you see that the A outputs the same values as the curl pattern, and the B are the false values. The reason that I encourage you to use the dispatch is that most of the time you also want to, besides the values that are true, you usually also want to do something with the values that are false. Now let's continue taking a look at some other components. You're probably familiar with the series and range components explained in the 101, so I'm going to skip those also. Instead, let's take a look at the sequence component, and that's a component that's usually overlooked sometimes, but it can be very helpful, for instance, in generating tags for geometrical objects. So let's insert the component and let's see what it does. It's also located under the Sequence tab, and it's right here. Let me insert a panel to see its outcome. Now the nice thing is that it works the same as a series component, but instead of using only integers or numbers, you can specify whatever sequence you want. So the first input, the C, is the amount of elements you want to specify, and the default is set to 10. But let's insert a number slider, so we can control this amount manually. Now if you take a look at the P, those are the characters you want to specify for your sequence. Now the default is set to the alphabet in capitals, but we can insert any sequence we want. So let's insert a panel. Let me insert a custom sequence. Like just as an example. Now if I insert this value here, you see that the sequence changed. the nice thing of this sequence component is that if it surpasses your actual sequence you're inputting, so the sequence I inputted stops at the letter P, but if I continue growing my sequence, you see that it repeats the first letter. So you see that it starts adding the Q, and then it adds another Q, then QW, QE, etc. So that's really nice. So you never have to worry that your sequence will run out. And the F is the optional formatting mask, but we can leave it at the default. I think that's fine. Now the next three components I want to take a look at is the duplicate data component and repeat component, and also jitter, which is also located under the sequence tab. So let's insert them all three. So it's duplicate data, repeat data, which works a little different, and also jitter. Now let's make another list of elements. Now the first component, our duplicate data component, is really straightforward. It just duplicates the data with an integer or a number you specify. So now if I take a look at the output, you see that after number 5, the sequence gets repeated. So if 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and that sequence is repeated 20 times, or the amount of times I specify using this integer slider. Now there's another option, which is the order, and default is set to true, but if you insert a Boolean toggle to see what happens if you set it to false, you see that now it doesn't retain the order. So what it does now is that it first copies the first item from the list, which is in our case the 1. It copies it 4 times, then it goes to the next one, it copies it again 4 times, etc., all the way to the end. So that's if you want to retain the list order, or if you want to do it per element or per item. Now let's take a look at the next component, which is repeat data, and let's use the same list. And this component will repeat a list or a set of data with the amount you specify. So it will basically just repeat the list, how many times you want it to be repeated, let's say. So let's say I want to have, from a 1, 2, 3, 4, 5 list, I want to have 11 items. This component will repeat the list until your number is satisfied, the amount of repeats you want, the length, let's say. Now let's take a look at the last component, which is jitter. And this basically will scramble a list with a value you specify. So let's use the repeat list for a change. That one goes into the L. And the J is the shuffle strength, which requires a number between 0 and 1. And the S is the seed value, which requires an integer. And now, depending on your shuffle strength, the output will randomly reorganize the list. Well, not completely random, pseudo-random, and that's the seed value is because of that. And if you change the strength, you see that like if I set it to 0, you see that the list is completely the same as your input list. And if I set it to 1, you see that all the items are reorganized. And the I output is the index map of the shuffled items from your original list. Now let's go to the last two components I want to show you in this lesson, which are also located under the Sets tab. One is located under the Sequence tab, and which is called Stack Data. It's a very nice component, especially for us architects. And the other component is called Partition List, which is under the List tab, which basically work together in tandem. Now let me insert a panel and let me create again another random list. just some random animals. So let's set it to multi-line data. And the first one goes into the D, which is basically the data you want to stack. And the S, that's the pattern basically of how many times you want to stack a certain item. And that requires a list of integers and needs to be the same length as your input list. So we have 5 animals in our list. So we also need to specify 5 integers of the amount of stacking we want to achieve. So let's say something like that. Now let me insert a panel to see the result. So you see that depending on the combination of the D and the S input, you see that the item from the D input got duplicated the amount of times from how many times we specify in the S input. So cat got duplicated 2 times, dog 4 times, fish 6 times, mouse 9, and bunny 2. Now the partition list can also be very helpful if you want to order this list a little bit better. Let's say you want to give every item its own branch. So let's connect our D to the L. And the S, that's basically the partition size, which coincidentally is the same as the stacking pattern. So now if I connect a panel to this output, you see that right now the list is the same as our previous one. The only thing is that now it's ordered. I mean, every animal has its own branch, which can be very helpful as well. Now let me show you another example where this component can be very helpful in our field. So let me insert this component again, stack data. And let me draw in Rhino a mass, just a random BREP. Like a fancy twisting shape. So let's insert a panel and let's copy it 1 time over, so we have 2. So first we're going to specify the floor-to-floor height of the certain programs you have in that tower, let's say, if this would be a building mass. So let's say you have a lobby that is 6 meters high. Then we have office spaces, which are 4.5, for instance. Then we have some apartments, which are 3 meters high. And then on the top floor, we have a restaurant, which is 4 meters high, just as an example. Now in the second one, we need to specify how many times we want to duplicate those floors, or how many times that program appears. So the lobby appears only 1 time. Let's say we have 5 floors of offices. Then we have 7 floors of apartments. And we have 2 floors of restaurant. Now combining these together and using the contour component, this one, we can generate the floor slabs really easy and really fast. So let me link in our BREP. And the second input is the base plane, which is set to the XY plane, which is fine. Now the offset, those are the offsets we want to insert, which is the stack data. The only thing is we need to add them all together using the mass addition component. But before that, we just need to insert the very first floor, which is located, in our case, also at the 0, 0 plane. So we need to insert a 0 into this list. And we're going to use a component we've used before, which is called list insert. So let me insert a slider and set it to 0. And the index we want to insert it is also 0. So we can use the same slider. Nice. So now we can add all the values together. And we want to have the partial results. Now, if we insert the partial results into the offset, you see that in Rhino, we have all the slabs defined. So let me adjust the mask a little bit better, because as you can see, I drew it a little bit too high. So we can move this one a little bit down. And let me hide it. Let me turn these off. Great. So if I zoom in a little bit and go back to our list just to verify what happened, you see that we have one floor which is 6 meters high on the ground floor, starting at the ground floor. This is the lobby. Then we have 5 levels of office. 1, 2, 3, 4, 5. And then we have 7 floors of apartments. So it's 1, 2, 3, 4, 5, 6, 7. And then to finish up, we have 2 floors of restaurant, these 2. And the last slab is actually the roof. So that's not a floor slab, but the roof. This is a really fast way to get floor slabs using the stack data component. And I use this component a lot for quickly generating formal options using just a base shape in Rhino and checking quickly the areas, let's say, given a certain program. This also brings us to the end of this lesson. In the next lesson, I'll talk a little bit about sets of primitive data types, and those are basically numbers, text, and booleans. How to manipulate them, find items in a list, and organize them using some helpful components from the Sets tab. See you in the next lesson.